All right, everyone, welcome. Today we're going to dive into a condition you will see constantly in your practice, color vision deficiency, or CVD. Our focus isn't just on the biology, though. It's really about equipping you with the practical, evidence-based tools you'll need to effectively guide your patients from day one.
So, here's our roadmap for today. We'll start with the basics. Then we'll take a really critical look at common interventions like those special glasses you see online. After that, we'll explore some practical digital aids, talk about how to manage acquired CVD differently, and then peek at what's on the horizon with gene therapy. And we'll wrap up with the crucial role of daily accommodations.
So let's start with the fundamentals. Before you can advise a patient on how to manage their condition, you really need a rock-solid understanding of the why and the how of it all.
So what are we actually dealing with here on a biological level? It seems like a simple question, right? But getting this answer precise is absolutely key to clearing up some of the common misconceptions your patients will have.
At its very core, you can think of CVD as a hardware issue. The problem is with the cone receptors. Those are the photoreceptors that are responsible for color perception. So if one or more types of these cones are either faulty or just plain missing, the brain simply doesn't get the complete data set it needs to interpret the full spectrum of color. It's that simple. And it is absolutely critical to distinguish between the two primary origins here. You've got congenital CVD, which is inherited, it's there from birth, and as of right now, there's no cure. Then you have acquired CVD, which develops later because of other factors. This distinction is vital because, as we're about to see, the management approach is completely different for each one.
Okay, let's move to our next section, and this is a big one. This is where you'll really need to be the voice of evidence-based reason for your patients. We're going to take a critical look at those so-called colorblind glasses.
I promise you, you will hear this question or some version of it over and over again in your career. Patients see these viral videos online and they come to you with really high hopes. Our job is to manage those expectations with clear, factual information.
This slide really gets to the heart of it, the gap between the marketing claims and the clinical reality. These glasses do not restore color vision. Let's be clear on that. What they do is use filters to increase the contrast between certain colors. This can help some people with mild red-green CVD, but it is not a cure. The effect is totally temporary, and a big 2022 meta-analysis found there just isn't enough evidence to support their general use. Their effectiveness is highly individual, and we have to present it that way.
So, when you're counseling a patient, these are your key talking points. They reduce night vision, so they are an absolute hazard for driving at night. They're often seen as a non-medical device, so insurance typically won't touch the often very high cost. It is our job to provide this full, unvarnished picture.
Okay, so while the glasses have their limitations, technology offers some unbelievably practical and accessible tools. This is where we can offer patients immediate, tangible help in their day-to-day lives.
These tools literally transform a smartphone into a powerful assistive device. Apps like Colorblind Pal can actually name a color for a user. You just point your camera, tap the screen, and it tells you this is dark red. It's amazing. Others like Visolve or even the built-in settings on a computer can alter the display to make colors more distinguishable. Now, these are not treatments, they're incredibly practical aids.
And this is a perfect example of their real-world impact. Think about a chemistry lab, where a color change tells you everything about a reaction. This app allowed students with CVD to participate fully and accurately. It's a brilliant example of how technology can provide access and independence.
All right, now let's pivot back to that other category we mentioned earlier, acquired CVD. With these cases, our diagnostic and management strategy shifts completely. We're not just managing the symptom anymore, we're investigating the underlying cause.
So if a patient comes in and reports a recent change in their color vision, your alarm bells should be ringing. As you can see here, the list of potential culprits is long. It ranges from undiagnosed diseases like diabetes or glaucoma, all the way to side effects from common medications. This is where your role really expands. The key is collaboration with the patient's primary physician. Often, addressing the underlying condition or just adjusting a medication can reduce or even resolve the color vision symptoms entirely.
So we've established there's no cure for inherited CVD. Well, not yet. Let's take a look at the cutting edge of research, because what's happening in gene therapy right now is genuinely exciting stuff.
This 2022 study gives us a little glimpse into a potential future. So what they did was, researchers took children with achromatopsia, that's complete colorblindness, and after giving them a single gene therapy injection, they used an MRI to look for any changes.
And this is the headline result right here. 2 out of the 4 children in those 2, the follow-up scans showed new signaling pathways lighting up between their cones and their brains, activity that simply would not have been possible without the therapy. It's a remarkable proof of concept that maybe, just maybe, the hardware can be repaired.
But, and this is a really important but, we have to remain scientists. We have to temper our excitement. This was a tiny study on young kids with a very specific and very rare type of CVD. We have no idea if this would work on adults or on the far more common red-green deficiencies. It's promising, yes, but we are in the very early days.
Okay, this brings us to our final and, perhaps most important section. Away from all the high-tech labs and future cures, this is where you, as a clinician, can make the biggest immediate difference in your patients' lives, advising them on practical accommodations.
These are such simple, low-cost changes that can make a world of difference for a student. Just think about a pie chart where the sections are only different by color. For a student with CVD, that chart is basically useless. But add a pattern or a simple text label and boom, it's perfectly clear. This is all about designing for accessibility. And the exact same principles apply to the workplace. Of course, the specific adjustments will depend on the job, but the goal is always the same. Remove color as a barrier to getting a task done. It could be something as simple as labeling wires for an electrician, or allowing an office worker to use an app to check their color-coded spreadsheets. So, to wrap it all up, for inherited BAFVD, we're not healers, we're guides. Our primary role is to debunk the myths, to provide evidence-based counsel, and to empower patients with the tools and the strategies, both technological and environmental, to help them navigate a world that's been designed around a full spectrum of color. And I'll leave you with this final thought to consider. As all these assistive technologies and inclusive design principles become more sophisticated and widespread, do we eventually reach a point where the functional impact of CVD is so minimal that the societal push for a biological cure becomes, well, less urgent? It's a fascinating question about that intersection of medicine and society. Okay, that's all for today.